In this lesson, we'll explore an important algebraic technique known as completing the square. When completing the square, the general procedure is as follows. We'll be given a quadratic expression in the standard form ax squared plus bx plus c, and our goal is to find a, h, and k so that we can express this in the form a, x plus h quantity squared plus k. We'll talk in the future about why we want to be able to do this and how this is useful for problem solving in calculus and beyond, but for now let's focus on understanding how we transform the expression on the left into the one on the right. Now, in a previous mathematical setting, you may have learned a specific expression that you can memorize that you would add and then subtract to the expression on the left in order to do this. But what I want to focus on here is how we can do this without having to memorize some specific expression. We want to focus on understanding the mathematics so that we don't have to memorize some specific expression. So let's start with this expression on the right-hand side. We want to get our quadratic in the form ax plus h squared plus k. So we're just going to expand that out, meaning we'll go ahead and expand our x plus h quantity squared. So we'll multiply x plus h times x plus h. Go ahead and do that on scratch paper and you get x squared plus 2xh plus h squared. The next thing that we'll do is distribute that a through, so go ahead and multiply every term in our parentheses by a. We get ax squared plus 2ahx plus h squared plus k. Now remember, our goal was to express ax squared plus bx plus c in the form on the right-hand side, which we now know is equal to this expanded form that we just obtained. So in order for these expressions to be equal for all values of x, meaning to represent the same expression, we need corresponding coefficients to be equal to one another. In other words, we need the coefficient of x squared on the left to equal the coefficient of x squared on the right. So we need capital A to be equal to little a. We need the coefficient of x on the left to equal the coefficient of x on the right. So we get capital B is 2ah. And finally, we need the constant coefficient on the left to equal the constant coefficient on the right. So we need C to equal AH squared plus K. And again, the important thing to keep in mind here is that you didn't have to memorize any specific technique or complicated expression involving numerical values of your coefficients. You simply look at what you want on the right-hand side, expand it out, and identify your coefficients. So let's look at an example. We're given the quadratic 2x squared minus 3x plus 1/8, and we want to complete the square. So we want to express this in our form a x plus h quantity squared plus k. So again, I'm just going to expand that right-hand side. We want 2x squared minus 3x plus 1/8 to be in this form a x plus h squared plus k. I'll go ahead and expand that out. We know that we're going to get ax squared plus 2ahx plus h squared plus k. Identifying our coefficients, I need the coefficients of x squared to be the same, which gives us little a equals 2. We need the coefficients of x to be the same, so we need negative 3 to be equal to 2ah. And we need the constant coefficients to be the same, so we need 1/8 to be equal to ah squared plus k. So now that we know a, we can plug a into 2ah equals negative 3. That's going to give us h is negative 3/4. And finally, we can plug both a and h into ah squared plus k equals 1/8. Go ahead and do that on scratch paper and you can solve for k, and you'll get k equals negative 1. So we've now shown that 2x squared minus 3x plus 1/8 is equal to 2x minus 3/4 quantity squared minus 1. And notice that as a check, you can always just quickly multiply out the right-hand side and show that you get what you had on the left. So if we do that here, we're going to get 2, and then inside our parentheses we get x squared minus 2 times x times 3/4, and then plus, when we square, we get 9/16 minus 1. Working that out, we get 2x squared. 2 times 3 over 4 gives us 3 over 2, and then the whole thing is multiplied by 2, so we get minus 3x. 2 times 9 over 16 gives us 9 over 8. Minus 1 gives us 9 over 8 minus 8 over 8, so we get plus 1/8, which is what we expected. So you can always check your work by quickly multiplying out at the end. And again, what I want to emphasize here is that we didn't have to memorize anything. We simply started with what we were given, the 2x squared minus 3x plus 1/8, and said, okay, what is it that we want this to be equal to? And then we just multiply out, and the key step is here, where we identify coefficients. So keep this technique in mind. It's a lot easier than memorizing a specific expression to add and subtract. That technique will be prone to mistakes if you memorize the wrong expression or forget what you memorized in an assessment setting. So keep this in mind, as this emphasizes the actual mathematics that you need to solve these problems. So finally, let's go ahead and use this to solve a quadratic equation. So I have the equation 2x squared minus 3x plus 1 over 8 equals 0, and I want to solve this by completing the square. So here's our equation. The first thing that I'll do is just go ahead and rewrite our 2x squared minus 3x plus 1/8 in the form that we just obtained. So 2x minus 3 over 4 squared minus 1 equals 0. Now to solve this equation, I'll go ahead and bring the 1 to the other side. So I get 2x minus 3/4 squared equals 1. Next thing I'll do is divide by 2. So I get x minus 3/4 squared equals 1/2. Moving on, I'll take the square root of both sides. Remember, when I take the square root, I get plus or minus square root on the right-hand side. So I have plus or minus root 1 over 2. Remember, that's the same thing as plus or minus 1 over the square root of 2. We'll go ahead and rationalize the denominator, meaning we're going to multiply the top and bottom of this by the square root of 2 so that we don't have a radical in the denominator. So we get x minus 3/4 is equal to plus or minus the square root of 2 over 2. Finally, we can add 3/4 to both sides, so we get that x is equal to 3/4 plus or minus the square root of 2 over 2. And of course, as you know, with a quadratic, we'll get two solutions. So 3/4 plus root 2 over 2 and 3/4 minus root 2 over 2. So one of the important applications of completing the square is that we can use it to solve quadratic equations, as we just did in this problem.